Hi, I'm Christopher Dean. I'm the Technical Product Manager here at FastCap Systems.
And I'm Joseph Lane, the Director of Engineering at FastCap Systems. The ultracapacitors are not that dissimilar from batteries when you're designing energy storage into the system, but there are a few pretty big differences to keep in mind. The first thing is that they're rechargeable. So you have, if you have a generator connected to your capacitors, you don't necessarily have to worry about how much energy the capacitors can supply.
Mm-hmm.
That being said, over the long term, they have a linear voltage discharge curve. And so if you're operating within a certain voltage window, you're going to have only so much energy that you can expel and maintain and stay within that voltage window. So that's one thing to keep in mind.
So another similarity to batteries is kind of the form factor and the mechanical design of the capacitors, which is very similar to a battery. Our capacitors come in sizes very similar or not exactly the same to a AA or a D size or a double D size battery. So those can be easily interchanged, whatever system that they're being designed into.
Yeah, definitely. Right, so as you go up in the sizes, you generally go up in capacitance, and usually up in power as well, although that depends on how you actually configure the cells within the tool string.
Mm-hmm.
A lot of times we'll interface the capacitors with a DC to DC or AC to DC converter to actually charge the ultracapacitors. And we do that for a couple of reasons. One, it's nice to control the charge on the capacitors so you're not shorting out any sort of generator or battery supply. And that gives you a way to monitor the charge on the capacitors as well. But unlike batteries, you don't really have to baby the charge, period. You don't have to go from like constant current to constant voltage. You can pretty much charge these in any way that you want to. We usually use constant current because it's pretty simple. But they can take as much charge as you can throw at them.
Yeah, they'll kind of like embrace the peak power, and so they're happy to take on large current loads or small current loads, as opposed to batteries, which will kind of lose life if you're charging and discharge at different rates.
Yeah, exactly. And then the other thing is usually when you're powering a load, you want to look at how much energy the load is going to consume over time, but also how much peak power the load will take.
Mm-hmm.
And the reason for that is because, if you are operating within that voltage window, both will contribute to the drop in voltage. So if your peak power is substantial, you'll want to maintain a configuration that has high power capability, but also has high energy, just so it doesn't draw down too far because of the energy.